Good day to you from Anagalactic on this Friday, June 26th. Over here we have a simple list of words. We're just going to make sure that we're all on the same page with these words. This is a series that concerns a very specific mistake that I made in a video exactly 2 years ago, where I inverted a force valence in one of my most popular videos. And there was a workup to this. I was trying to explain the strong force in order to relate it to the Bošković force curve, in which field of study I have made what appears to be a significant discovery. But in explaining this to a rather advanced audience, which is not normal attendance to my station, and this is indeed a screenshot of that video, where you'll see to my left the strong force curve. The term strong force has to be disambiguated. In Wikipedia, they take care to do so, but as we're going to find out, Wikipedia has actually made a significant error in this exact diagram of what is termed the nuclear force, which I call the strong force, but there's an historical development that makes that an ambiguous term, and Wikipedia attempts to treat that and does a very poor job of it. But this diagram that is displayed here is from the Wikipedia article on the nuclear force, and I'm going to be going back over that so that we have, you and I both, have a much clearer perception of what Wikipedia is attempting to display here. I claim, not without reason, that this is the force relation between two protons at closest proximity, actually showing the binding range and actually showing the binding sphere, which is reasonable to say, but that is part of my discovery. Now, all of this is to be going very swiftly, which is always dicey. I don't like going swiftly. Usually I'm quite tedious. But you have to balance these. The tedium comes from the proof sequence, which has to be rigorous. But the swiftness comes from what's most important to us as scientists, which is the understanding, the actual insight which we all seek. At whatever phase or level, you want the answer. You have to get the solution. If all you get is a theory, or all you get is an ambiguity, you fail, and it's on or off. Either you get the understanding or you don't. And if you don't get the understanding, you literally have gotten nothing except another piece of information to dump in the database for someone else to figure out. Now, we are attempting to get to the very fundamental balance of the universe, because the universe is balanced. It doesn't appear to be chaotic. The very basis of rational logic is that everything has a context which makes logical sense. No rational man argues with that. There is nothing ultimately spooky in this universe. And that's the basis of physical science. This diagram here you'll see is closely related to the Wikipedia diagram we were just looking at, which is entitled the nuclear force, which I call the strong force, which is the relationship between two protons at close proximity. The reason for doing this rapidly is because it's extremely important to understand the mistake that Wikipedia made, which contributed to my horrendous error, which turned off my audience and really sent some pretty powerful people away. Now it's 2 years later, and I'm going to show you what it was that I was trying to say, which got the attention of some top-notch physicists. We will be going as rapidly as possible while still making sure that we understand what this diagram shows. Thank you very much. We'll be right back. Good day. We're back in our series on this force curve, a strong force curve, the relationship between two protons at closest proximity. Protons have a charge. They naturally repel. That is thought. There is a range for the repulsion in an atomic, actually a nuclear system, How do protons cling together? They do so up to 92. We can find the elements all the way up to uranium. At the concentration of 92 protons, they're unstable. They naturally fall apart, a process called fission. Certain words being used at this scale, the smallest scale of all, have changed meaning and have acquired new meanings. There was a new discovery in the 1960s by a man named Gell-Mann having to do with what is now known as chromodynamics, having to do with the three-part system to the proton. It's more complicated now because of the advances made in a very specific and very restricted form of physics. An attempt is made to make the universe entirely out of particles, which I found quite a shocking axiomatic basis for what is called the standard model of particle physics. It's almost 100% mathematics. Because what does fly out of a proton-proton collision is visible in what used to be called a bubble chamber. I'm not sure what it's called now. But these pieces, these shards of what would have to be called the inner structure of the proton has been shattered. Just a proton is called an ion. The proton can be in an ionic state, as of course it is in plasma, which constitutes 99.9% of the sun. The nature of the proton has been explored from these experiments done in what used to be called cyclotrons and now are called hadron colliders. Hadron is a term from the standard model of particle physics, where it's quite baffling, at least to me, and I don't think that I'm rather unusually stupid or slow in this sense. There are hadrons, there are baryons, and there are fermions. And that's just the top level. And they overlap. So that, much to my surprise, during my several times research of this incredibly complex and convoluted topic, it turns out that the proton is not only classified as a hadron, but it's also classified as a fermion. And the reason is the quarks. And the quarks are, I think, the one and only significant discovery. I would say at a certain level, that's a little unfair, but the major discovery, a very important discovery that came out of these experiments, was the fact that the proton certainly has a structure. And that was inductively obvious, that is, it's rather to be expected, because the proton does something either in space or to space, and it bends it. It can be thought of that way, although it doesn't necessarily have to be said that way. It is said that way in space-time, which is considered to be bent space-time, which means that not only space is bent, but time is bent due to the geometry, a most interesting system which I've covered in several videos. So I want to explain why I'm showing you this diagram. Here is that diagram, an unbelievable blunder, which I had made before. I'm expanding this so you can see that that is taken from the Wikipedia article. This diagram is wrong. It can be considered correct if you add a footnote. Actually, this diagram is strictly wrong. I'll be showing that the person who made this diagram, it's labeled the Reed force. There's absolutely no information on this. You have to make this simple. Science is the art of simplifying the facts and the knowledge so that it's absolutely crystal clear what's being said. At this level, it has to be done. That's why we're doing what we're doing. So there's a little philosophy for you. We'll be right back. Thank you for tuning in. We will be covering these terms. You see I have the Reed lacuna at the bottom. Lacuna essentially means black eye. It means so much to me to know that someone is listening to this, because I lost my audience 2 years ago when I had a chance to achieve one of the goals of this platform, to have an audience, to share this, to talk about it, debate it if necessary. This is the natural process of science. So I do this in order to get substantial insights for humans to improve their life. This is about breakthrough understanding to get to a higher level. However you construe that, we'll be right back. Thank you very much.